Last week we talked about two types of random variables, discrete random variables and continuous random variables. In this video we are going to talk about how to calculate the mean, again the average, of a discrete random variable. And there's a pretty simple formula for calculating the mean of a discrete random variable. And this is the formula that you see on the slide right now. This might not look too simple, but all this is saying, actually first of all let's talk about the notation a little bit. Instead of using x bar for the mean, if we're talking about a random variable, we will typically use the notation mu of x, which is notation you've seen before. We talked about that back in chapter 2. That Greek letter mu is just the symbol that we use to represent the mean. So in this case, if we want to calculate mu of x, the mean of some discrete random variable, all we do is we take each of the possible outcomes in our random variable x. So here we've labeled those x sub 1, x sub 2, going all the way up to x sub k. And we multiply each of those possible outcomes by their corresponding probabilities, which in the formula we are representing with p sub 1, p sub 2, and p sub k. So again, this might look like a complicated formula, but the idea is pretty simple. All you do is you take each possible outcome and you multiply it by its corresponding probability and then add all those values together, and that sum will give you the mean of your discrete random variable. A more succinct way to write this formula is just to say that you're taking the sum, remember that Greek letter sigma means sum, of each value in your probability distribution and multiplying it by its corresponding probability. So you could see this formula represented in either of these two ways. So let's do an example to show just exactly how this formula works. Let's say that you have a car dealership and they've collected some data over time, and they have found that the probability distribution that they sell a car during the first hour of business on a given Friday. So here on the slide we see the probability distribution for this situation. In the first hour of business on any given Friday, the dealership knows that they can expect to sell 0, 1, 2, or 3 cars in that first hour. And they also have enough information that they know what the probability of those 4 situations are. There's a 30% chance that they will sell no cars, there's a 40% chance that they will sell 1 car, there's a 20% chance that they will sell 2 cars, and a 10% chance that they will sell 3 cars. Now the first thing you might want to do is check to make sure that this is a legitimate probability distribution. And remember, to do that, you simply need to sum up all of the probabilities and make sure they sum to 1, in which they do. 30 plus 40 is 70, 70 plus 20 is 90, 90 plus 10 is 100. So we've got 100% of our various possibilities accounted for. So that means we can go ahead and start calculating the mean number of cars that our dealership can expect to sell. I already mentioned that one way that we can notate this is to use mu of x to represent our mean. Another way that we might see this notated is you might see capital E of x. This notation means that we are calculating the expected value of our random variable, which in other words is just another way of saying we're calculating the mean. Keep in mind though that just because we're calling this the expected value, that doesn't mean that this is the exact value that we expect to happen each time our situation occurs. It just means that on average, this is what we expect to have occur. So let's go ahead and calculate this for our car dealership. Remember, we take each of our values of x and we're going to multiply it by its corresponding probability. So we take 0 and multiply that by its probability of 0.3 plus the situation where we sell 1 car, multiply that by its corresponding probability of 0.4. Then the situation where we sell 2 cars, multiply that by 0.2. And then the situation where we sell 3 cars and multiply that by 0.1. So when we work that out, we'll get 0.4 plus 0.4 plus 0.3. And when you add those values together, you get an average of 1.1. So on average, we expect to sell 1.1 cars during the first hour of business on any given Friday. Now, of course, selling one full car and 1/10 of a car is not a realistic situation. Remember, this is just an average. So don't be concerned if the mean that you calculate isn't an actual possibility within your probability distribution. It's very likely that it won't be. This simply means that we can expect to sell, on average, 1.1 cars during the first hour of business on a given Friday. So that means that we would expect most often to sell one car, which shouldn't be too shocking since that is the result that has the highest probability in our distribution, with a probability of 0.4. But we'll expect that most of the time our sales during the first hour of business on a given Friday will be somewhere between 1 and 2 cars.